Ever wonder what a speeding bullet and a boiling pot of water have in common?
Besides being dangerous, I don't know, I'm curious.
Well, they both have energy, and that's what we're diving into today, work and energy.
Sounds fascinating.
We'll be looking at this physics textbook 10, workandenergy.pdf, to really get into it, beyond just memorizing definitions.
Well, I like that, getting into the nitty-gritty.
Exactly. Because it's amazing how often we use these terms every day without really, understanding what they mean scientifically.
Absolutely.
Like, I put a ton of work into getting this show ready, but I have a feeling a physicist might disagree.
Well, it all depends on context. The textbook makes a clear distinction between how we use work in everyday conversation and its formal scientific definition.
Okay, so how does a physicist define work then?
Well, for work to happen in the physics world, you need two key ingredients: force and displacement.
Force and displacement. So,
Yeah.
like, if I'm pushing a car, I'm using force. But if that car doesn't move,
No displacement.
then it's not work, even though I'm totally straining.
Exactly. It can seem counterintuitive.
Yeah.
The textbook even gives the example of a bullock pulling a cart. The bullock exerts force on the cart moves some distance, and there you have it, work.
Okay, I think I'm starting to understand. But then the textbook mentions positive and negative work. That's where I get a little lost.
Think of it this way. Positive work is when the force you apply is in the same direction as the movement.
Like pushing that toy car earlier.
Exactly. The effort and the motion are in sync. Negative work is when you're applying force in the opposite direction of the movement, like when you apply brakes to a moving car.
So if I'm trying to open a really sticky door and it's a total struggle, is that negative work?
Precisely. Your muscles are putting in effort, applying force, but the door's movement is going against that force. Negative work in action.
Wow, I never thought about it like that. Now, we've been talking about work, but what actually makes work possible in the first place? That's where energy comes in, right?
Absolutely. Energy is like the fuel for all this force and displacement stuff. The textbook describes it as the ability to do work.
The potential to do work, not just the act of doing it.
Exactly. Like, think of a coiled spring. It's full of potential energy just waiting to be released.
Or a cricket ball flying towards a wicket, that's kinetic energy, the energy of motion, right?
Perfect example. The textbook uses that one too.
Yeah.
The wound-up toy car is another good one. It's not moving yet, but it's storing up that potential energy, ready to transform into kinetic energy and take off across the floor.
So we have these two basic types of energy. Kinetic, the energy of motion, and potential, the energy of position or configuration.
You got it.
And that brings us to one of the most fundamental laws in physics, right? The conservation of energy.
Exactly. Energy cannot be created or destroyed, only transformed from one form to another.
So no matter what, the total amount of energy in a closed system stays the same.
That's the idea. The textbook uses the example of a falling object. At its highest point, it has maximum potential energy.
Because of gravity.
Right. As it falls, that potential energy is converted into kinetic energy. But the total energy of the object remains the same throughout.
That's mind-blowing. Even though the object is changing, speeding up as it falls, the total energy remains constant.
It's a fundamental principle that governs the entire universe.
Mm-hmm.
Now imagine if there were no energy transformations.
What would that even look like? Could life as we know it even exist?
Interesting questions. We've talked about the ability to do work, but what about the rate at which work is done?
Isn't that where power comes in?
Got it.
Huh.
Power is all about how quickly work gets done. Or, another way to think about it, how fast that energy is transferred.
Okay, so the faster the work, the more power.
Exactly. The textbook uses this analogy of two people climbing up a rope.
Okay.
They both, they exert the same amount of work to get to the top.
Right.
But if one person climbs faster, well, they're more powerful.
Makes sense. So like with light bulbs, a higher wattage means it uses more energy per second, so it's brighter. Is that right?
Perfect example.
Yeah.
Watts are how we measure power, that rate of energy transfer.
This is really starting to make sense now. It's not just theoretical, it's everywhere. We've been talking about mechanical energy this whole time, the energy of motion and position, but I know there are other types, right?
Oh, absolutely. Mechanical energy is just one type.
Right.
We've got light, heat, electricity. We see them all the time, even if we can't, see them directly like a moving object.
So like the light from a lamp, that's electrical energy being transformed into light energy.
Exactly. And the heat you feel coming from the lamp, that's also energy transformation.
Yeah.
From electrical to thermal energy.
It's like a chain reaction of energy transformations. And then there's chemical energy, like what we get from food. Our bodies are amazing at converting that into energy we can use to move, think, even record this podcast.
That's right. Our bodies are incredibly efficient energy transformers. And to think about it, that chemical energy in our food, it ultimately comes from the sun. Plants capture light energy through photosynthesis and turn it into chemical energy. They either eat those plants or animals that have eaten plants, and boom, we're powered by the sun.
Wow, that's wild when you think about it, this huge interconnected web of energy. I'm definitely starting to see how important energy is to, well, everything.
It's pretty remarkable when you stop to think about it.
It really is. We kind of take it for granted.
Yeah. But without these constant energy transformations, the world as we know it would just stop.
So as we're wrapping up this deep dive into work and energy, what's the main takeaway you hope listeners are left with? What's that one aha moment?
For me, I think the most important thing to remember is that energy is everywhere.
It's in everything.
Exactly. It's the driving force behind every bit of change and activity we see in the universe.
Wow.
From the smallest atom to, the largest star. It's incredible.
It's like the secret code of the universe.
Yeah.
And understanding energy and those transformations helps us appreciate, like, the inner workings of everything around us.
Yes. And it's
Yeah.
not just about, memorizing definitions and equations.
Right.
It's about getting a deeper understanding of how the universe works at its most basic level.
This has been such an eye-opening deep dive. I don't think I'll ever look at the world the same way again. A rolling ball, a lightning strike. It's all about energy transformations now. It's like we've been let in on this incredible secret.
Right.
This whole other level of understanding how things work.
And it's not just about, satisfying our curiosity.
Right.
The more we understand about energy,
Yeah.
the better we can deal with some of the big problems in the world today.
Exactly. Like finding cleaner, more sustainable sources of energy. That's a big one.
Absolutely. This knowledge can really help us build a better future.
I'm with you on that. This whole conversation, this deep dive, it's really been eye-opening. From rethinking what work even means to, realizing that energy is behind literally everything around us.
It's pretty amazing.
So for our listeners who are hopefully just as fascinated by this stuff as we are, what's one last thought you want to leave them with?
How about this? Next time you're just going about your day, take a second to really think about all the energy transformations happening all around you.
Oh, I like that.
The sun warming your skin, your phone lighting up, it's all energy.
It's easy to forget, just how fundamental it is.
For sure.
Well, this has been amazing. Thanks for joining us for this deep dive into work and energy.
Thanks for having me. It's been fun.
And for all you listeners out there, we'll catch you next time.